I'm not going to worry about it. I run the tests all the time anyway. All right, the next one, week 4, grind 75, week 4, problem 8 is called rotting oranges. So let's get into that one. You're given an n by n grid where each cell can have one of 3 values. 0 representing an empty cell, 1 representing a fresh orange, and 2 representing a rotten orange. Well, Kakina, hello. In fact, Kakina says, are you following the grind 75 schedule or just doing them as they appear? Yeah, I'm not dedicated enough to do a schedule, right? So grind 75 is basically divided into 8 weeks. So after 8 weeks, you got to be done. I stream 2 or 3 times a week, and I can only get, depending on how complicated they are, 2 to 4 maybe problems solved per stream. So I might be able to get it done in 8 weeks, but I haven't been trying. So it's not a goal of mine to blast through them as fast as I can. The goal is for me to learn Rust by doing them. And hopefully being somewhat entertaining. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. Okay, so this is kind of similar to the problem we just solved, number 200. Which one is this? 994. Okay. I can see why they were put together here in the grind 75. 99. Ooh, that's the bottom one here. The 0994. Rotting oranges. Okay. Save that. Create the file. Jump to the file. And this is just a standard impulse solution. And I actually have to put pub struct solution, boom, and return 0. And get it to build. Oranges rotting. Okay, let's rot some oranges. This time, let's not use the hash set. Let's actually use the grid itself. What would be a good approach? So we can just walk through each grid position and look up, down, left, right. If it's a regular orange, we can look up, down, left, right and see if there's a rotting orange next to it. And if so, we just switch to rotting. If there is, like here, there's nothing or regular oranges, then we don't do anything. And if there's a space, we just skip it. So yeah, let's walk our way through. And what we can do is we want to be able to return -1 if we can't convert all of the regular oranges into rotting oranges. And then otherwise we return the number of minutes. So we need to keep track of how many, so number of minutes is basically how many turns, how many passes you did over the array. All right, so we have 2 examples here, 3. Oh, we got 3, good. Okay, so let's add those in as our tests. So for example 1 is, we're expecting 4. The actual is solution, or is rotting. And we're just passing a vec of these guys. Like that. And I do have to put the vec bang in front of each of them. Like that. So that's example 1, and this should fail, right? Hello? Oh, I'm not on the test page here. There we go. Okay, now it's failing. And then we'll do the same thing for example 2 and example 3. So test ex2, grab these lines, and then ex3. Quote 1, no. Quote 2p, no. Quote 0p, nope. Dang it. I thought it would be still in one of the buffers. Okay, and then we have to change these things here 2, 1, 1, and then 0, 1, 1, and then 1, 0, 1. Like that. And this should be a -1 because we can't convert them all. And then this should be 0. So this test is going to pass because we only have a vec of 0 and 2. Yeah. All right. So we should have 2 failures now. Good. All right. So we're going to count the minutes. So let mut minutes equals 0, and then we'll return that at the end. And now we just need to say, okay, so we're going to make a pass. And if we converted any regular oranges into rotting oranges, then we know we can continue passing. We can continue looping. If we do a pass and nothing has changed, then there's no point in keeping on going because we're done. Right. So we can just have a let mut changed is true. I'm going to assume we're able to change. Let's say while changed. And the first thing we do is set changed equals false. Right? And then we're going to loop through every line and column, row and column, and look up, down, left, right, just like we did before. Except if we're going to do this with the vec, so I can't use the dir and I can't unconditionally check. I actually have to do some fancier logic. So we can say for row, comma, line in. Oh, right. So we're going to be modifying this stuff. So let mut next is equal to grid clone. So next iter enumerate, and then for call character in line iter enumerate. Right, so this will give us the row and the column, and then we can look to see if the ch and we have to generate, that's right, we have to generate a brand new map or grid from the existing grid, which is what we're calling next. So we have to create a brand new grid. Step, vec bang. Let's just fill them all in with, and this is next 0.len. We'll fill them all in with zeros, and then for those we just do that, and then next len. So this is basically a, I guess I could have just said next.clone. That's right. So we'll actually, you know what we should do is fill them in with -1s. That way we know if we make a mistake. Because now we can say if ch is equal to 2 or ch is equal to 0, right? Because 2 is rotten orange and 0 is an empty cell. We just copy those into the step. Row call is equal to ch. Right, and then we don't need to do anything else then. So now it's a fresh orange, and now we got to look up, down, left, right to see if there's a rotten orange. So we need to look, right, so we need to say if row is greater than 0 and the next of row -1 call is equal to 2. Or row, oh, let's see, this is awkward. Row is less than next len -1 and next of row +1 call equals 2. Or call is greater than 0 and next of row call -1 is equal to 2. Basically, I'm looking to see if there's a rotten orange around us, and I want to avoid over-indexing or under-indexing a lead. Oh, sorry, Jewel Wayne, sorry, you said are suggestions allowed? Yes, absolutely. I'm 100% up for backseating. col is less than next of 0 len minus 1, and next of row col plus 1 is equal to 2, then we're going to change this one, because it's a 1, right? So this is, if it's a 2 or a 0, do this. If it's a 1, right? So our next step is going to be changed to this, and we're going to make it a rotten. Else, step row col is just the one that was there from next. We also want to say, okay, we're changing it, so changed is true. I think we're good, right? Is there anything? Oh, we do need to be able to figure out. Oh, first of all, I need to increment minutes every time we come through here. And then we do need to be able to determine if we weren't able to change all of them. And I think that's here. Right? If we set any to 1 during any pass, we could just say finished is false. And I could just set finished to true up here. Actually, it doesn't matter there, but a finished is true here. And then if it ever gets set to false, that means we didn't do it. If we didn't change anything and finished gets set to false, that means minutes we have to return -1. So if not finished, then we're going to return -1. Otherwise, we're going to return minutes, how many minutes it took. I think that's all we need to do. We've got 2 warnings, so I'm missing something. Oh, this next. Oh, right. Each time through the loop, we actually have to update this, which means it's probably running infinite. Yeah, we got an infinite loop there. Let's kill that. And see, Rust is helping me figure out what my bug is, saying I'm not modifying next. So after we go through the loop, we're going to then set next is step, like that. And now, bacon test. We got an off by 1 error. Right, so because we're incrementing minutes, and then we go through here, and we're done, but we've incremented to the minute where we didn't actually need to do the work. So the easy answer there is just subtract 1. Or start at minutes at -1. Right. Okay, that fixed those tests. So this works. Let's copy paste. It just barely fits on the screen. There we go. Paste. Submit. Namram says, which problem ID is this? This is number 994. And we got it. Runtime is 2 milliseconds. So it beats 66% of the problems. And memory takes 2 megabytes, which beats 97. I can't imagine. Okay, let's take a look at the one that uses all the memory. Using a VecDeck. I see. Maybe all this allocation around the VecDeck is taking up time. Because all I'm doing is, I mean, I'm using a lot of memory, right? By cloning the grid and creating a new one each time through the loop, and it has to get dropped each time here. So, but maybe that only counts as 1. And then in terms of speed, let me see what a slow solution looks like. Oh yeah, so they're doing the up, down, left, right. Oh, this is interesting. Yeah, so they just count up how many oranges there are. And if we get down to 0, we return count, meaning that's how many minutes it took. And if we didn't change anything, we return -1. What's this doing? Count plus 3. Oh, I see. That's interesting. So they're using the grid, but they're not overwriting. I mean, they're not making a copy of the grid. What they're doing instead is saying for each count. So the first time through it's 0, 1, 2. And then the next time through it's 3, 4, 5. And then it's 6, 7, 8. And then 9, 10, 11. That's interesting. You could run out of numbers, right? If the grid's large enough and it takes too many quote unquote minutes. But that's really a really interesting approach to avoiding making a copy of the grid itself. Oh, well, you have to copy it here. I think you could probably put mute in front. I wonder if I could do that. Can I do that by doing this and getting rid of this next business? Well, let me commit these changes first. Git status. Yeah, let's clippy this. Evo says, does the end state memory get counted or the total memory used throughout? And Noram says max mem usage. Yeah, I never really looked up that information to see, but I'll believe you, Noram. Oh, we do have a little thing we can clean up here. Yep, this is true. We can get rid of this extra layer of, it looks uglier, I think, but there you go. And now it's saying we don't need to clone it. Oh, that's true. That's absolutely true, right? Because we only read next and then we reassign it. So yeah, so that was going to be my next thing. So let's git status. Oh, I don't need to. Git add source. Git commit -m problem 994. Adding oranges. So my question now is, can I put mut here and get rid of all these next and just change those to grid? Like that? Will that build? It does build. The fact that we're modifying that shouldn't matter for the solution, right? Let's go back here. Let's do that. Paste and submit that. Yeah, so that also works. In terms of, how can I tell? Can I click here? Yeah, oh yeah, so it uses slightly more memory, which is interesting. So I don't know how much you can believe that. And the runtime is the same. But it saves us having to create another variable. So it's slightly cleaner, I think. Let's go with that. Git status, git commit -am, remove unneeded variable. Oops, gotta spell needed right. Okay, good. Do I have time for one more? I think so.